Okay, this is a little overview of Unit 8 in Algebra 1 or Algebra 1 Honors. This is entitled Systems of Equations. This is a pretty good video for anybody who was absent when we did this, or anybody who just needs a little refresher in preparation for an SOL or the Unit 8 test, or just for anybody who just needs some extra help with systems of equations. So this is a not all-inclusive video. It's just an overview of the major topics. I could change some of the questions around a little bit, but if you know just the major topics through this video, you're going to be just fine. Systems of equations just means just that, more than one equation. So here's the general idea, and I just captured this from Google. If you look really carefully, you can look right here. You can see you've got two lines and they intersect right where that point is, right there. That's actually the solution. You can see these two lines intersect right there. You can see all kinds of points of intersection, and that's what the whole idea is. Where do two lines collide? Where do they collide? And that's a specific ordered pair. So a typical answer would be like 3, -5, 0, 4. Once in a while, you're going to get lines that are two equations that actually form the same line, and that's going to be coinciding solutions, and that will be all real numbers that are infinite solutions. You can write it as that, or infinite solutions. Sometimes you're going to get two lines that are parallel, and if two lines are parallel, they will obviously never intersect, and that would be no solution. Those are the two special types, kind of the extremes. Most of the time, though, there's going to be an answer. Okay, so let's start this by graphing. Let's just try one. These are both solved for y, so pretty easy. Just identify the slope. Slope is 1/2, and the b is 7. Here the slope is 3/2. It's also a good review of y equals mx plus b, and the b is 3. So what you do, we'll start, doesn't matter where you start, I'll start here. The b is 7, so we put a point at 7. And the slope is 1/2. So from this point, we're going to go up 1/2, put a point, up 1/2, up 1/2. You want to put a whole bunch of points because we don't know where they're going to collide. So from here, we can also go down 1 and 2 to the left. If you remember way back from Unit 4, when we officially graph lines. Now, I don't usually connect the dots, because if you do, it's kind of difficult to see where the point of intersection is going to be. So I just put a whole bunch of points. Okay, down here, second equation, I start at 3. So put a point at 3. Slope is slope is 3/2. So from here you're going to go up 3/2, put a point, up 3/2, and there's a point, which is the same point from before. We'll put a little box around it, and that is the answer. That's the point of intersection. So we got an answer at 4, 9. So the answer here, solution would be 4, 9. Couple ways to check this. You could check this on the graphing calculator if you put this in y1 and this in y2, and go ahead and graph them. You can actually use the table or the graph to find out that this is the point of intersection. Or the old-fashioned way, you can plug in the 4 for x and the 4 for x here, and then see if you get a 9 as your answer for both of these, and you should. Solving a system by graphing. We'll do 2 examples of this. Okay, actually there's 3 examples, I think. Okay, this case the slope is 3/4. This one's really quick. If you notice the slopes are the same, we're going to get an answer very quick. So slope is 3/4. The b, which is the y-intercept, is -7. This also has a slope of 3/4, and the b is 5. So if you start at -7, put a point here. Slope is 3/4. So you can go up 3/4, up 3/4. Okay, you also go down 3/4 here, and then here you can start at 5. But if you notice the same slope, up 3/4. So it's impossible for these lines to ever intersect. And you can see, I can just add a few here. You can see if I were to connect these dots, these lines are parallel because we have exactly the same slope. Notice it's 3/4 here and 3/4 here. Because they will never intersect, there is no solution to this equation, to the system. Okay, sometimes you're going to have to be asked to find the same point of intersection, but without a graph. Now you could actually solve both these for y and graph them, but it'd be kind of a pain. So we have this thing called substitution. So we're going to solve a system by substitution. And what you want to do is find the variable with no number in front. There's a 3, a 2, a 4. There's really no number here. So we're going to solve for x. So I'm going to isolate x. So this is plus 4y, so I'm just going to subtract 4y from both sides. There's a lot of writing with a lot of these, but it's really not that difficult. If you take your time, it really isn't bad. But I will tell you this, I'm going to warn you, there's a lot of writing. So x is equal to this. I'm going to put a little football around it. I call it the football. I'm going to put a little football around that. Remember, all of this is equal to x. So x equals this entire thing. What I just did was I solved this for x. Now, why did I do that? Well, notice there's a y here. If I actually go up in this to take this football and put it in for this x, I will get rid of all of my x's. Because remember, there's a y here and there's a y here. That's the idea. You want to get rid of a variable. So what we're going to do is we're going to take 3, that's this 3, times x. But see, x is the entire football. So instead of writing an x, I'm going to write negative 4 minus 4y. See, all of this represents x. You see how we have 3x? But instead of an x, this whole thing right here represents x. So this is 3x. This whole thing is x. Now, plus 2y equals 8. Notice there's no x's here. That's what we want. We want to get rid of a variable. So let's go ahead and distribute the 3. So we get negative 12. And again, it's not hard at all. Once you get the idea here, it's just take some time, and I am writing with my mouse, so it takes a little bit longer. You'll notice that in a lot of my videos. Okay, I'm going to combine my like terms. Be careful here. A lot of kids will mess this part up. Negative 12 plus 2 is negative 10. So negative 10y equals. I'm going to go ahead and add 12. Add 12 here and add 12 here. That's going to get 20. I'm going to have to, once in a while, I have to skip a step or two because there's a lot of writing, and I have to stay within the screen when I record these videos. Y equals negative 2. Now, remember, you got to get an x and a y. That's the whole idea. And y we already know is negative 2. Now, to get the x, what you do is you take the negative 2 and go back to the football, inside the football. Now we know what y is. So x is what? Negative 4 minus 4 times y. But remember, y is negative 2. So if you crunch all these numbers, you're going to get negative 4 plus 8, which is 4. And once again, here's your solution. And you can actually check your answer by plugging each one of these numbers in, and this should work. Substitution. Okay, sometimes the football will already be given to you. Here's a case where y is already equal to 16 minus 2x. So I'm going to take the football and go down here. So I'm going to write it as 3x minus 2. Y is 16 minus 2x. Once you get the hang of this, it's just the process. It really is not bad at all, I promise you. Okay. See what I did? I got y all by itself, so that's the football. Go down here and put it in for y. Notice all the y's are gone. That's what you want. One variable must disappear when you do this. So I'm going to distribute a negative 2. So what I'm going to have is 3x. Negative 2 times 16 is negative 32. Be careful, you got a double negative here, so plus 4x. And all of that equals 24. So combine your x's. 3x plus 4x is 7x. I'm going to go ahead and add 32 to this side, and that's going to give me 56. Divide by 7, and x is 8. So we know that x here is 8. By the way, you always want to go alphabetical order. This is x and y. Sometimes this will be an A and a B. Always put your answer in alphabetical order. So if it's like a P and a Q, sometimes they'll do that to you. Just go alphabetical order here. So x comes before y, so we'll go x first and then y. But if it's A and a B, you want A and then B. Okay, now x is 8. Go to the football, and what you're going to have is 16 minus 2 times 8 is 16 minus 16, which is 0. You can actually have 0 as part of your point of intersection. And that is your answer. And you can check it by plugging everything in. And that is substitution in a nutshell. Okay, another process is called elimination. Rather than create the football or graph it, and once again, we can still solve these for y and graph them and get the point of intersection. No problem at all. But it'd be kind of tedious because you have to move the 3x over, divide by negative 2. So why do that? If you notice that all of these are lined up, notice how your x's, your y's, and your constant. What you want to do is you want to get the same number in front of the variable and hopefully either opposite signs or the same signs. Notice, look at the y's. I've got a -2 and a +2. If I were to add these two equations together right now, these would cancel. -2 plus 2 is gone. So if I add these two, these are gone. What I'm going to get is 5x equals 5. Divide by 5, and x is 1. So right off the bat, we have an answer. It won't always be this quick and this easy, but just want to give you the idea here. Now, we know x is 1. Go back to either equation. Doesn't matter which one. I'll use the bottom one because it's positive. So I'll go 2, remember it's 2x. I want to get y right now. I want to get this y. But I know x is 1, so 2 times 1. Remember, we just got x. X is 1. 2 times 1 plus 2y. So we don't know what y is. So 2y equals 4. Okay, that's a 2. So I'm going to go ahead and subtract 2 here and subtract 2 here. And I'm going to get 2y equals 2, divide by 2, and y is 1. So actually we're going to answer at 1, comma 1. And to check it, you just go back in, plug everything in, and you should be good. Okay. Applications of systems of equations. Applications of systems of equations. These are the word problems. These are the ones where and I know I only did one elimination here, but to do this, we're going to use elimination. So I'm going to kind of show you elimination again. Okay, what you want to do, applications, is a word problem. Because it's kind of like when are we ever going to use this in real life? Kind of the applications of it. So we're going to apply it. We're going to use the same processes. We're going to apply it. Okay, you're selling tickets to a high school basketball game. Student tickets cost $3, general admission. So what we have are two types of people are going. We have the students. S for student. I always use the first letter of the word. Sometimes people, the X and Y, and they'll go, let X equal students. That's such a pain in the butt because then you got to go back. Oh, what was X again? So I just go S for student and G for general. So students plus general, the number of students tickets plus the number of general tickets is equal to 350. That's what it says. The second equation is quite often the money equation, wherever you see a dollar sign. Okay, a student ticket is $3 each, so 3S. A general admission ticket is $5 each, for a total of $14.50. In a word problem, you want to make sure you use every single number. If you haven't used every single number, you're probably doing something wrong. Make sure every number is used. Okay, we can actually use elimination. You can actually use substitution also. I think elimination is a little easier. Here's the idea. I have a 3 here. Let's get rid of the S's. We can get rid of the S's or the G's. Let's get rid of the S's. I have a 3 here. I need this to be a 3. So what I'm going to do, right now it's a 1. I need it to be a 3. So what I'm going to do is I'm going to multiply the entire top row by 3. And then we'll go ahead and subtract. I'll show you. So distribute the 3. What we're going to have is 3S. The bottom row I can leave alone. So 3S plus 3G. You see, I'm distributing the 3. Everything gets multiplied by 3. 350 times 3 is 1050. Now, notice I have the same number here. If I add these together, nothing's going to cancel. But if I have the same number with the same sign, let's go and subtract. See, 3S minus 3S is gone. That's the whole idea. We got to get rid of a variable. So 5G minus 3G is 2G. And all of that equals, just do the subtraction, 400. Divide by 2, and that means we have sold 200 general admission. So number of student, number of general admission, we sold 200. The good thing about a word problem is all your answers are going to be positive and usually nice whole numbers. If you get, 1.74, you can't sell 1.74 tickets, right? So anyway, another good thing about a word problem is if this is 200, getting the second variable is really easy. If we know they add up to 350, we've already sold 200 here, so this has to be 150. So we sold 150 student tickets and 200 general admission tickets. And you can check it, just plug everything back in and you'll get it. Okay, in honors algebra, if you're in regular algebra, you can skip this one. This is more of an honors algebra type question. This is what we call a mixture question. It looks really, really tricky, but I don't think it's that bad. Let's just figure it out. All right, a dairy owner produces low-fat milk and whole milk. So we know there's low and whole. That makes sense. For a total of 100 gallons. That's not too bad, right? We know there's low fat, and we know there's whole for a total of 100. Okay, the second equation is a little tricky. The mixture is the low fat's 1% fat, so we're going to write 1% as 0.01. Remember, not 0.1, that's 10%. 1% low fat plus 3.5% whole milk is 3.5% fat. Remember, that's 0.035. Now the mixture, we're going to take the 100 gallons, the same 100 gallons, and we're going to mix in the 2%. So we're going to multiply it by 0.02. This looks tricky. It's really not that bad. You just have to think a little bit. Okay, which by the way, when you do all this multiplication here, that's just a 2. So I'm going to just cross this out and put a big 2. All that becomes a 2. Okay, now let's get rid of the L. So let's multiply the whole top by 0.01. Everything by 0.01. So we're going to get is 0.01 L plus 0.01. I'm going to go make this a 0. It's going to make subtracting easier. W equals 1. Yeah. Now, subtract. These are gone. Be careful with this. You're going to get 0.025 W equals 1. Now, you take your calculator, and you take 1 divided by 0.025, you're going to get 40. You're actually going to get 40. So we know they add up to 100. There's 40 gallons of whole milk to make this mixture. And we know they add up to 100, so the low fat has to be 60. Don't let word problems confuse you. They're really not too bad. Okay. Finally, the last section of this unit. The last section is what we call solving a system of linear inequalities. Now think back in math. We have actually solved equations. Check. We have solved inequalities. Check. We have solved systems of equalities. That was back on the first slide. Check. What we haven't done to complete the picture is solve a system of linear inequalities. Again, it looks really, really hard. It's not. If you think back to in Unit 7, we did this, but with one of them. Remember, we just graphed one and we colored. Okay, this is not any more difficult. This is just a couple of these, and then we're going to color at the end. So here's what we want to do. This is not solve for y. Let's just find the intercept. So imagine I'm going to cover this up. If I cover this, here, I'll go ahead and just do this and erase it. If I cover this up because it's 0, y is equal to, remember, treat this like an equal sign. Y is equal to -8. So that's the y-intercept. Now, if I cover this up, x is equal to -4. Writing these straight lines is going to be tricky with this, but I will do my best. And that's a dotted line. So we know that the line of this inequality, arrows, still use arrows, looks like this. Wow, this is not easy. Anyway, looks like this. Now, remember what I taught you way back in Unit 7. What we did is we plugged in a 0 for x and a 0 for y to see if this is true. Is that true? Is 0 bigger than -8? See, what we want to do is we want to know, are we coloring on this side or this side? So we're going to plug in 0, 0, which we just did. That was true. So that means we're going to color all of this, but we're not going to color yet. Just put little arrows here reminding us that the answer is to the right of the dotted line. All of this is gone. See where my mouse is? All of this is gone. We will never, ever color here, ever. Okay, the second one is x equals, remember, pretend this is an equal sign. X equals 4. So put a point at 4. This is a solid line because we have a line here, and again, I'm going to try my best to do a straight line. Takes kind of a steady hand. Oh, wow. I usually don't do it that well. Anyway, x is less than 4, so we know it's going to be to the left of 4. So see what we have now. The area is right through here so far. It's all of this. So this is gone, this is gone. The answer is somewhere right in here. Well, I didn't mean to do that. Get rid of that. Okay, and then our last one, we have y is less than -3. Remember, it's a horizontal line. So put a point at -3, dotted line. So we have a dotted line going this way. Remember, it's still a line. Don't forget your arrows. Y is what? Bigger than negative 3 or less than negative 3? Y is less than negative 3, right? So we're going to go everything that is below this line. So if I put a negative 4 here, right, that's true, right? That's a true statement. So it's to the right of this, to the left of this, and below this. So here's where you would color. And this is your answer right here. Now, if you want to check this, here's what you do. It's actually pretty easy. If you want to check this answer, if you want to check this whole thing, here's what you do. You actually pick any point in this colored region. So you might want to pick 2, -5, for instance. So that's right here, right? 2, -5. So what you do is you plug in a 2 for x and a -5 for y, anywhere you see it, and see if all of this is true. And it should be. So that's the best way to check your answer when you do this. Pick any point where you colored and plug it all in and see if it's true. That's true, that's true, and that's true. We know our answer is correct. Okay, one more, last one. Let's just practice one more. All right, what if we have just 2 lines, 2 diagonal lines? Let's just see. Okay, intercepts. So what I'm going to do is cross this off, and y equals 5. Remember, treat it like an equal sign for now. And then I'm going to cross this one off, and x equals 2. Dotted line. Look at the inequality. Dotted line. Arrows, please. Arrows, 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 arrows. Okay, the easiest point in the whole wide world to check is 0, 0. So I'm going to plug in a 0 for x and a 0 for y. It makes the whole thing 0. Is 0 less than 10? Yes, it is. So this point here that I just checked works. So it's going to be everything here. So you will never, ever color here. It's to the left, kind of to the left of this line. Okay, this one real quick. Let's do the same thing. Let's cover this up, and y equals 3. Let's cover this one up, and x equals, be careful, -1. Okay, this time you have a solid line. See the line? Solid line. Alright. The study hand that I don't have. I've seen better. That's alright. Okay, almost done, almost done, almost done. Plug in a 0. We want to check it. What are we shading here and here? Remember, we can still shade here. We can still shade here, and we can still shade here. We just don't know yet. So let's plug in 0 for x and 0 for y and see if that's true. Is that inequality true? Yes, it is. So we're going to be shading towards 0, which is this way. So we're going to have a little kind of a triangular region, looks kind of like a teepee. And we're going to shade in right here. I love teepees. I would have loved to have lived in a teepee. Pretty cool. And there it is, everything in there. And again, to check it, what you could do is pick a random point. I use a little red dot. This is like 0, -4 right here. That's just the point I'm going to check. So if I plug in a 0 for x and a -4 for y and a 0 for x and a -4 for y, you will see that both of these are actually true. So that's a great way to check it. Okay, I hope this has been helpful to you. I hope that you